Let's go to page 372. This is lesson 6.3. And this lesson is to use similar polygons. Two polygons are similar polygons if corresponding angles are congruent and corresponding side lengths are proportional. So similar means first they have to, similar means same shape. So same shape means have the same angle on the matching part, the corresponding part. And since they're different size, then their length ratio will have the same ratio. Okay? So again, here's a summary. The corresponding angles, so all the corresponding angles have to equal. Okay? And the ratio, all the corresponding sides will have the same ratio. So AB over F over EF and so forth, all these will have the same ratio. Okay? So let's go over example 1. It says use similarity statements. In a diagram, you have triangle RST. So this wiggly line means similar, okay? Similar to triangle XYZ. Okay, so over here it says list all pairs of congruent angles. Okay, so since they are similar, so the corresponding angle will be congruent, and you have to match up letter carefully. So you see over here, see the letter. So angle R will be congruent to angle X. Angle S will congruent to angle Y. Angle T will be congruent to angle Z. So over here. So you just match up the letters. So R match with X. S match with Y. T match with Z. So the corresponding angle has to be congruent. Okay? Now B, check the ratio corresponding sides that, okay, check that the ratio of the corresponding side lengths are equal. Okay? So you just go and line it up again. Use so RS. So you want to start with either from the shortest to longest or vice versa. That way you don't get confused. Just do it in an orderly manner. So over here first they match the shortest side. So RS over XY equal to 20 over 12 equal to 5 over 3. Okay. And then you go to the medium length. Okay. So over here they kind of just do it in different order, but it's better to do it from the shortest, then the middle one, and then the longest one. Okay, so the middle one is TR over ZX, so 25 over 15 equal to 5 over 3. Then do the longer side. So you got so you got ST over YZ, so you got 30 over 18. Okay. And so equal to 5, 3. So since I have all same ratios, okay, therefore they are equal. So therefore they are similar. Okay, so again, similar triangle, they all have to have the same ratio. Now another way of checking the ratio is this. Okay, there's another way to check ratio very quick to see if they are similar. Okay, so the triangle, you have 25, 30, and 20, right? And this one, you have 12, 15, and 18. So what you do is you arrange from the shortest to the longest. So you got 20, 25, and 30, right? So what you do is you factor out into the lowest numbers. So this one you can factor out the 5, so you get 4, 5, 6, right? This one, again, you do the same thing. Again, you can factor out the 3, so you get 4, 5, 6. So after you factor out, notice the 3 sides ratio of 4, 5, 6. The 3 sides are ratio of 4, 5, 6. So since they have the same ratio, same number, therefore they are similar. Okay? So here's another way you can check if they are similar or not. So you can factor out as much as you can and look at the 3 numbers. If they're the same, okay, then means they are similar. If they are not the same, means they are not similar. Okay, okay, let's go to example 2. And the method I just mentioned is very quick. Okay, see like this one over here. Determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of ZYXW to FGHJ. Okay, so to check, okay, so again to check, right? First you write it arrange in order, so you got 12, 16, 20, 24, right? And the second one, again arrange from the lowest, to highest. So you got 15, 20, 25, 30, right? So this one, there are multiple 4s, so you can find. Now, if you cannot see the 4, then you can, it's okay to divide by 2 first. So you got 6, 8, 10, 12. And you can divide by 2 again. So you get 3, 4, 5, 6. Okay? This one, all these are multiple of 5, so you can divide by 5. So you got 3, 4, 5, 6. So you see that? So from here, you can see that they are exactly, they're all matching. So the range, so they are similar triangles. Okay? Okay. The next, write a similar statement from the scale factor. Okay? So since these are all matched, right, you can kind of divide both sides by these numbers. So here would be your scale factors. See right over here? So it would be 4 to 5. But be careful. They want you to do the, so you have to watch the order. They want you to do the Z, Y, X, W to F, G, H, J. Okay? So they want you to do this first, the big one over the small one. So in this case, the scale factor would be 5, right? See the 5? Because this already matched already, so you can cancel it out. So it'd be 5 to 4. So here's another way, a quick way of finding the scale factor. Okay? Or you can just do individually, like the book did it. You know, you just go on 15 over 12. Okay, you get 5 to 4. Okay. But we have to do the write a similarity statement. Okay. So again, if you look at the picture, first you have to do all the angles, right? So you're going to do all the angles. So let's go and do the. Okay. So let's just go and do the hash marks. So let's first do the angle, the right angle. So angle J is congruent to angle W, right? That's the right angle. Then we're just going to do one arc, 2 arcs, 3 arcs. So you can do it in certain order. So one arc would be angle F is congruent to angle Z, right? So again, what we're doing is we do the right angle first, and we do the one arc, then two arcs and 3 arcs. Okay, so that's how we're going to write it. Okay, so the one arc and then the 2 arcs would be angle H is congruent to angle X, and the 3 arcs would be angle G is congruent to angle Y. Okay, and then let me see, and the corresponding part, the proportions. So that's it. Okay, and if you want to write the matching part again, you can just do like what the book says, right? Just matching up each time. So again, I like to do it in order. So I like to do it like from the lowest to highest, and from the shortest to the longest. So the shortest one would be WX over JH equal to 5 over 4, right? Or equal to 15 over 12, which is 5 over 4. Okay, and then the next one would be ZW over FJ, and this again equal to 5 over 4. And the next one would be ZY over FG, again this equal to 5 over 4. Okay, and the longest one is YX over GH, again this is equal to 5 over 4. Okay. Okay. Let's go to example 3. Okay, in the diagram, okay, so you have this triangle over here. So you got 9x12, and you got 12, 16, 20. Okay. Okay, you want to find the x. So since they're similar, okay, so you want to find x. So again, you can do any matching. Okay, as long as remember the proportional equation, right? So you can match up, then you will be fine. Okay, so you can have the 9 over 12. So this over this will equal to this over that. Okay, and you cross multiply. So you got 12x equal to 9 times 20. and then divide by 12, so this cancels out, so x will equal to, so simplify, okay, so divide by 3, divide by 4, and x will go to 15, okay, and that would be your answer. So just kind of match up things exactly, okay. Okay. Let's go to page 374, the perimeter. The ratio of length in a similar triangle is the same as the scale factor. Theorem 6.1 shows this is true for the perimeter of the polygon. Okay? So over here, perimeter of a similar polygon. If two polygons are similar, then the ratio of the perimeter is equal to the ratio of the corresponding side length. Okay. So if this polygon is similar to this polygon, then if you add all the four sides together over that, it will equal to ratio of any side. Okay. And again, remember this is just like the proportional lesson that we went over, right? Remember the one looks like a ladder. Again, you can add all that as long as you match things up. Okay. Okay. Let's go to example 4. From the perimeter of the similar figure, a town is building a new swimming pool. An Olympic pool is rectangular with a length of 50 meters and width of 25 meters. The new pool will be similar in shape but only 40 meters long. Okay? From the scale factor of the new pool, so you have to pay attention. It says new to Olympic. Okay, so new pool would be 40, Olympic would be 50. Okay, so it would be 40 to 50. So scale factor would be 4 to 5. Okay. Now, personally, I don't really like it write this way. So you can just write 4 colon 5. Okay, so again, because the new pool would be similar to Olympic pool, the scale factor is a ratio of the length. So scale factor is 4 over 5 or 4 to 5. Okay. Okay, now B, from the perimeter of the Olympic pool and the new pool. Okay, okay, so here's an Olympic pool. So this would be 25, 25, 50, 50. So the Olympic, the pool of the perimeter of the new, the perimeter of the Olympic pool, just add all four sides together. So 50 plus 50 is 100, plus 25 plus 25 is 150. Okay, so 150 is the perimeter of the Olympic pool. Okay, now to get the new pool, you just times by the scale factor. So 150 times by 4 over 5, okay, and you get 120. Okay, or another way to do it is by finding the length of each side, okay, and then just add them all together after that. Okay, so 50 times, so you can 40, right? So it'd be 40, 40, 20, 20, okay, for the new pool. So you can, if you just use a scale factor, you can find the length of the new pool. You're going to find out that the length would be 40, the width would be 20. So 40, 40, 20, 20, you get 120. Okay, so you can use this way. Okay, again, you can use a scale factor. Use 150 times that. So 150 times scale factor will give you 120. So again, there are many ways you can do this kind of similar problem. Okay, let's go to page 375. Okay, similar and congruent. Notice that any two congruent figures are also similar. Their scale factor is 1 to 1. In triangle ABC and triangle DEF, the scale factor is 5 to 5 equal to 1. So you can write that triangle ABC is similar to triangle DEF, and triangle ABC is congruent to DEF. Okay? So congruent means same shape, same size. Similar means same shape but different size. Okay? Normally it's like that. But if you have this something that is same shape and same size, then it's congruent. Okay? But usually if it's not the same size, then it's usually similar refer to, they are same shape but different size. Okay, corresponding length. You know that perimeter of the similar polygons are in the same ratio as the corresponding side length. You can extend the concept to other segments in polygon. Okay, so key concept, corresponding length in similar polygon. If two polygons are similar, then the ratio of any two corresponding lengths in the polygons are equal to the scale factor of the similar polygon. Okay. So over here, example 5, use a scale factor. In a diagram, triangle TPR, so TPR, so this triangle is similar to XPZ. Okay? Find the length of the altitude of the PS. So again, if two triangles are similar, all the corresponding part will have the same scale factor. Okay? So to find out the altitude of PS, to find this over here, again, you can just write down your similarity, right, or any ratio, right? Okay, any proportions. So to do this, so you can just call, if you call this X, so you can just have X over 20, so you have this over this will equal to 6 over 8. Okay, you can do it this way, or again, you can do any matching part, right? You can have X over 6, you can have this over this will equal to 20 over 8, right? This over this, the altitude over the vertical equal to altitude over the vertical, right? So you can, so the nice thing about proportion or similarity is that you can write any way you want as long as you match up the corresponding part, okay? And from there you just go and solve, right? So this one you can just, instead of cross multiply, you just go and multiply by 20, okay? So you can cross out. So X will equal to 15, right? Let me double check. Divide by 4, you get 2. Divide by 4, you get 5. Yeah, so X equal to 15, okay? And that's it. Okay. So again, the key is, remember, you can write down any proportion equation you want as long as you match up the corresponding part.